We spent the last unit talking about congruent figures, and congruent means that everything about them is the same size. The sides are the same size, the corresponding sides are congruent, and the corresponding angles are congruent. So similar figures is a little bit different. Corresponding sides must be proportional or in the same ratio, and corresponding angles must be equal. Now, the reason that the angles are not proportional is because if I draw this angle, if this is 30 degrees, then so is it here. It's also 30 degrees. And if I just keep extending it, that's also 30 degrees. So what happens is basically your circle gets bigger, but it's still 30 degrees of that entire circle proportionally. So angles stay the same size, but sides are proportional. Okay, so the figures must be the same shape, but they are not necessarily the same ratio, or the same, actually, let's phrase that better. They're not actually the same size. Okay, the figures to show that figures are similar is like the little tilde that we use in Spanish. Congruent looks like that. It's like an equal sign with that tilde. That means they are the same size. Okay, similar looks like kind of a little sideways S, and they're similar. So that means that somebody took it to a copier and shrunk it down or blew it up. Your scale factor that we talked about with dilations is applied to the figure to produce a new figure. For instance, if you want to be twice as big, then you're going to use a scale factor of 2. Remember, if you want to get bigger, you use a number bigger than 1. A scale factor bigger than 1 makes the shape bigger, and a scale factor smaller than 1 makes the new shape smaller. Okay, so if I wanted to make it a quarter of the size, then I would divide by 4 or multiply by 1/4. 1/4 as big. So one way to determine whether the shapes are similar is we can match up our sides. Now when we match up our sides to see if they're similar, what we want to do is match our long with our long, and our medium with our medium, and our short with our short. It's the only way that we have to match them up. So we can see with these figures, and if they're going to be similar, all of the ratios have to be the same ratio. So I like to just pull all of my numbers over onto one triangle. So if I pull all of my numbers on the left over here to the right, and I noticed I used my angles to match everything up. My 2 equal sides match with my 2 equal sides, and my base goes with my base. Now, if you were to type these in and check them, maybe you don't recognize that 5/6 is not the same as 3/4. But 5/6 is 0.83 and 3/4 is 0.75. So since all three fractions or all three ratios are not the same, then these are not similar. Okay, if we look at these two rectangles, well, we can take, I'm going to go out here, and it doesn't matter whether you put your numbers on top or on bottom. So this time, just so you can see that it works the same, if you match, be careful, always match your short with your short and your long with your long. Don't go by what it looks like, go by the actual numbers. So the longest side of the rectangle in the middle is 6, so that's going to match up with 64 or with 24 on top and on bottom. And then we've got 4 and 4, which will go with our 16. Now, if I reduce all of those fractions, 6/24 is 1/4, and 4/16 is 1/4. And so since all of those all the way around have the same ratio, then they are similar, because they all have a scale factor of 1/4. So if I want to go from the big rectangle to the little rectangle, the scale factor is 1/4. Okay, if I want to go from the little rectangle to the big rectangle, then the scale factor would be 4. So it just kind of depends on whether you're getting bigger or smaller. Okay, then it says to write a similarity statement. So what that means then is we would say that rectangle A, we'd say A, B, C, D is similar to, and then we would match it up. So since I did it this direction, A, B, C, D, then I would say is similar to X, Y, Z, W. You can start anywhere, but wherever you start, you need to go in that same order. I could have said W, X, Y, Z, and then I would need to say D, A, B, C. So whatever you do, you need to go in the same order. Okay, if we look at this, we use the markings to match up everything. It doesn't matter, again, where you pull everything. I kind of like to look at it and see where I have the most space. But I'm going to match this up. So according to my markings, my 14 matches, JK matches up with AB, and KL matches up with BC, and LM matches up with CD, and JM matches up with AD. So I need to check all of those. If you don't know your calculator, you can do math, enter, type in 14 divided by 8, and math, enter it to see a fraction. That reduces to 7/4, or you can always reduce your own fractions. 7/4, that reduces to 7/4. And then 3 goes into 21 7 times, and 3 goes into 12 4 times. So these are also similar because their ratios are all the way around. Because I went, if I look from left to right, I got bigger, which means that my scale factor in this case would be 7/4. If I got smaller, it would be 4/7, because you need to be bigger than 1 to get bigger. And then my similarity ratio, it doesn't matter where you start. So I'm just going to start with A, B, C, D and say that it is similar to J, K, L, M. Again, doesn't matter where you start. Just once you pick a direction, go in that same direction on the other shape. So number 2, in the figure below, LMNP is similar to FGHJ. What is the scale factor from LMNP, so from my smaller shape to my bigger shape? That means I'm going to get bigger. And what is the value of X? So what we want to do is we want to set up proportions. And so again, this is one of the reasons why I was showing you earlier about setting up the fractions, because if you go ahead and move all of your numbers over onto one figure, it helps you to just go ahead and see the proportions that you need to use. So I can see that GF is going to match up with LM. So I'm going to put 15/12. I'm just pulling that number over here so I can put all my numbers on the same shape. And then FJ and LP, so that'd be 20/16. And then JH/12. Notice that all of them are going, all my numbers from the right-hand triangle, or the right-hand shape, are going underneath the left-hand shape. Now, again, they could go anywhere. They could go on top. You can move your numbers from the left shape over to the right shape. It doesn't matter. Right now, I just want to set it up. Now, since all of these ratios are equivalent, it doesn't matter which one I use to find 40/X. So I want to find 40/X, and actually we can see our scale factor. Our scale factor, 15/12, 3 goes into 15 5 times, and 3 goes into 12 4 times. So my scale factor would be 5/4 to go from the small shape to the big shape. That's my scale factor. If I wanted to go the other way around, then if I wanted it to get smaller, then I would say 4/5. So set it up, 40/X is equal to, and it doesn't matter which one you use, but you can use your scale factor if you want. So I'll just use 15/12 since I've used it before. Again, like I said, you could use 5/4. So we would cross multiply to get everything off the denominator and into the numerator. So it would be 15X is equal to 40 times 12, which is 480. And 480 divided by 15 is 32, so X is equal to 32. And what that means is that this side is 32. Now, when you set this up, I don't have any real way. Earlier I said match up small with small, medium with medium, large with large. Here's the problem. I don't know what those are because I don't have any measurements for them. So you have to use your similarity statement in order to match these up. So here's what you want to do. You look and you say, okay, AB matches with ED. Again, I'm going to pull all of my numbers over to one triangle so that I know how to work this. It just makes it easier that way. Okay, so AB matches with ED, so I'm going to put 40/32. And then AC matches with EC. EC is V, so I'm going to put 35/V. And then BC, which is 30, BC matches DC, which is W, so I'm going to put that over W. And so now you've got your proportions. We're going to use this one ratio every time. So I've got 35/V is equal to 40/32. If you cross multiply that, 35 times 32 divided by 40, you get that V is 28, And then if you do 30 over W is equal to 40 over 32, same ratio because we need them all to be equal to each other. Then you have 30 times 32 divided by 40. And you get that W is 24. So now we have the lengths of those two missing sides. Now with this one, CDE and CAB, notice if we need to, it's helpful to separate this out into two separate triangles. So if I've got CDE here, and then I'm going to go and put CBA over here so that I can see the whole thing. This is 11. And notice this whole side, you've got to pay attention to this whole side. It's x plus 15. Because you've got to add those two numbers together. So now, if I use my two triangles, just look at these two. Look at this one right here, and look at this one right here. Okay, so now we set up our proportions, and it doesn't matter, again, you can put them anywhere. I've got more space down here, so I'm gonna do the long side over, so it's gonna be, it's this piece, let me show you. It's this piece matches up with this piece. And then it's this piece that matches up with that piece. And so that's how we're going to set up our proportions. So I'm going to put x plus 15 over 15, and I'm going to put 11 over 7. Just like we did in our other ones, you can also use this statement right here. But what you want to be careful of is you want to be careful of using just x. There are certain situations when you can do that, but we don't know that right now. So when you set this up, you get 11 over 7 is equal to x plus 15 over 15. Be sure you keep your expression. So I have 15 times 7. So I get 7x plus 105 when I cross multiply equals 11 times 15, which is 165. So subtract 165 minus 105, you get 7x is equal to 60. And 60 divided by 7 is 8.5714, and it says to round your answer to 2 decimal places. So x is equal to 8.57. So you want to be careful with that. Notice how when you have just a letter between, a variable between those two letters, it's assumed that it doesn't go the whole length. If I want it to go the whole length, typically I'll show it like this, that whatever this is. So what it would be, 23.57, that's the whole length. So if I want it to represent the whole length and there are multiple segments across there, I'll show you the whole thing. So a larger cement court is being poured for a basketball in place of a smaller one. The court will be 20 feet wide and 25 feet long. So we need to look at this. The new court will be 25 by 20. The old court was similar in shape, but it was 16 feet wide. So it's smaller, and it was 16 feet wide. So the question is, what is the original length of the court? Well, I can compare length to width. So if I come over here, and some of you might not need to do this, that's okay. My original length, I'll call them the same variable. So I've got 20 over 16 is equal to 25 over L. So the ratio, it has a scale factor of 5/4. So it would be 4/5 as big as what it is. So you could do 25 times 4/5 and find out that the new length, or the original length, was 20. So you can use the scale factor. The scale factor would be 4/5 because from the new one to the small one. Or you can cross multiply this, and either way, you're going to get that the original length was 20. And the scale factor of the new court to the old court, from new court to old court, would be 20 over 16, which is 5/4. So I can take, so 5/4 goes from the big one to the small, or that's going to make it bigger. So it's what would I multiply the length by 5/4 to get the 25. So that's what you have to think about is, what did I multiply by 5/4 to get 25? So I can take 25 and multiply it divide it by 4/5, divide it by 5/4, and get what it is, what that length is 20. I think it's just easier to think in terms of proportions instead of multiplying by scale factors, because I get confused. And so I think that